Hello and welcome back to Advent of Code. We are moving on to day 6. So we are now, well, I'm now back up to the days where I haven't looked at these before. I haven't attempted to code them before. So I'm going into this blind. Before I read this description, I've made a slight change to how we load in days, just because we're now up to day 6. We've got more and more days. So with Zig, I thought you could do something like, could I put this import into some kind of compile time for loop, and then sort of programmatically or dynamically load each of the days. Unfortunately, you can't do that because the import built-in function needs a string. It will only accept a string literal. So I can't sort of construct a variable and put in like day file name here. That won't work. So we do have to at least list out all of the imports manually, but then I can go ahead and actually run the process on each of those by putting this into a namespace or a structure. I can now actually loop over all of the declarations in this structure, which is what I'm doing here. So I'm getting the type info of this day modules and looping over all of its declarations. This built-in function is just saying, okay, because this loops over all the declaration names, so it's looping over these names. And so we just need to get the name, and then this will actually get the actual field from this structure. And then we can do our typical process and append the solution to our array. Okay, we will be coming back to this. Don't know if I'll do it this episode, maybe in a future episode. I would like to start processing each of these days in their own thread. So when we load up our program, it's not going to have to hang to process all the days and then suddenly we get to see the UI. These can be spinning in the background, and the buttons will then become interactable once that thread has finished doing the process step. For now, it's not too bad. I am calculating the process duration. Is this printed? And it's still less than a tenth of a second, 0.057 seconds at the moment. Okay, so we're going to move on to day 6. So let's have a look at day 6. So the ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here. But you don't see anything besides lots of water. Yep. As you try to figure out what to do next, you notice posted on a wall near the ferry dock, boat races, open to public, grand prizes is an all expenses paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you'll get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. For example, so I'm guessing this will be in our puzzle input. This document describes 3 races, so the races are in the columns. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. The second race lasts 15 milliseconds. 40 millimeters, and so on. Your toy boat has a starting speed of 0 millimeters per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. So because the first race lasts 7 milliseconds, you only have a few options. You don't hold the button at all. At the start of the race, the boat won't move. It will have travelled 0 millimeters by the end of the race. Gotcha. Hold the button for 1 at the start of the race. Then the boat will travel at a speed of 1 millimeter per millisecond. We're just going to say it's going to have a speed of 1 for 6 milliseconds, reaching a total distance of 6. Hold the button for 2, giving the boat a speed of 2. It will then get 5 milliseconds to move. 5 times 2 is 10 millimeters. Okay. Since the current record for this race is 9, there are actually 4 different ways you could win. You could hold the button for 2, 3, 4, or 5 at the start of the race. In the second race, you could hold the button for at least 4. To see, okay, gotcha. In the third race, you could hold the button for at least 11. And no more than 19 on the boat, and still a total of 9 ways you could win. So one thing I'm noticing here is the amount of time you hold down the button for. There will be a single contiguous range of holding down time that results in a winning time. So we essentially just need to find the lower and upper bound. To see how much margin of error you have, determine the number of ways you can beat the record in each race. If you multiply these values together, okay, let's get our puzzle input. And our puzzle input is actually very nice and easy. So we'll do the test input for now, as usual. So we'll go to our test. As usual, I'm going to put this, come to this view, put this over here. Okay, so we're going to come to our test. Our line parser. So we're going to do our try parser skip word, and that will be time. Try parser skip white space, and then we need to do while we're not at the end, we will do read the number. I'm just going to do U32. Parser skip white space. This is going to be optional. And then we'll have to append this to a list. So time list append. This is only 2 lines, right? So this is line 1. So we're going to skip the distance. It's basically this. You know what? Reading a list of white space separated numbers is fairly common. So let's actually put this into our parser. So this read number, I'm going to do pub fn read number list. Actually, how common is it on our previous days? Yeah, a lot of the time it's white space. Although not always is it. Sometimes it ends on a character, sometimes it just ends because it's the end of line. So I'll do nchar, could be, it's an optional. And then we want to pass, I want to pass in the list. Or do we just want to pass in a slice? I'm going to comp time t is going to be type. And then the list will be a we don't know what the list type is going to be. So I'm going to do any type for that. So this will become generic. And we'll do void. Then it essentially becomes this, right? Our self is end. Self read number t. And if there is an nchar, we're going to do if self peak char equals char, then we'll break. So by putting this as any type, this will work on anything we pass in it that has a function named append, which is nice. So now this just becomes, okay, let's say we create a of our, what do we call it? Our time list is going to equal to standard bounded array E32. We'll just do like 16 for now, init with 0 items, and our distance list. And then we just do try parser read number list u32. Nchar will do that null, and the list is going to be time list. And I want a pointer to it, so at time list. Does that run? Oh, these need try. That works. And if I come here and I come to my step through debugger, I'm going to set a breakpoint once you've run all that. Let me get rid of the other breakpoints and just hit run. And then I want to peek into the time list. 7, 15, and 30, length of 3. 7, 15, 30 is in our puzzle import, and I want our distance list. Nine, 40, and 200. 9, 14, and 200. So that's all good. We can go ahead and stop our debugger. So now I want to put this into I'll leave that for now. No, I won't. I want a race, and a race will have a time and distance. I don't know if we're going to end up using maths. Maybe we want these as floats. In which case these would all be F32. Would that work? We're getting an error. Wait. Oh yeah, because it didn't even build. These can be U32 for now. But I'm gonna store the race. So to do this, we will just do for time list and distance list. These should be the same length, so I can iterate over both of them at the same time. So I can do time val and distance val, and I can do const race equals race. Time is going to equal float from int, and distance is going to equal float from int. And then we're going to try races append race. So we're going to create another array here. Let's call it race list. I'm gonna hoist these types up. So we're gonna do a const so this becomes a U32 array. That's a race array. Okay. So this should work. Zig build. And again, if I set it in a breakpoint, hit play. Look at our race list. I don't care about the time list and the distance list anymore. We have race time 7, 9, 15, 40. So that's the structure we care about. Okay. So this is all as usual, parsing the inputs. And now we want to actually compute the solution. Right, so let's come back. So we know, actually now that I'm thinking about it, maybe we do want these as just integers. Because essentially what we want to do is we want to loop over all the races. So for here's a race. We basically want to do 4, 0 to, well, we don't want to start at 0. Time. Restart time. Yeah, let's do these as U32s. And then we don't need to do this float conversion step. So we call this button time. So the move time is just equal to the race time minus the button time. And the distance traveled is equal to button time times move time. And then we'll say, okay, if distance traveled is greater than the race distance, gonna have ways to win equals 0. I'm gonna say lower bound equals 0 and upper bound we'll say button time is going to be standard.math.max int u32. So we don't want a const slice, we want a slice. This becomes a pointer. So we'll say race.ways to win, we'll add 1 to it. I think we want to swap these. So if button time is less than race dot button time lower bound, we'll say race dot button time lower bound, else if button time is greater than race dot button time upper bound, and race dot button time upper bound equals button time. I think that's our solution. So this button time is going to be a U size. I'm just going to call this I and then const button time. There we go. So let me run this. Oh yeah, and hit continue. So race 1, 2 and 3. It's saying ways to win is 4. Let's check if that's correct. There are actually 4 different ways you could win. You could hold the button for 2, 3, 4, 5. So 2 is our lower bound and 5 is our upper bound, which is what we have here. There are 8 ways to win the second race, where 4 is our lower bound and 11. So let's have a look at that. Yeah, 4 to 11, 8. Okay, and then we multiply them together. Which is fairly simple, so let me cut you out. Once we've done that, we'll just go ahead and loop over it again. This time it can be a const slice. And we'll just do our var answer, which is going to be this, starts off at 0, and our answer or do we? It's the multiplication of these. So we start it off as 1, and we'll times equal it by race.ways to win. Then we'll do our answer, and then we'll actually run this for real now. Oh no! Expected I32. All right, that's okay. We'll have to cast, or we'll just keep this as a I32. And then the answer is 288, which is this test answer here. So now we just need to do it on our puzzle input. So let me create our puzzle input. which is here. Oh, I need to change it to use our puzzle import, which is going to be day 06. And then here's our answer. What is that? 170,000? Is that correct? That is the right answer. Okay, that's cool. So how's part 2 gonna change this up? Let's have a look. As the race is about to start, you realise that the piece of paper with race times and record distances you got earlier actually just has very bad kerning. Okay, there's really only one race. Ignore the spaces between the numbers on each line. Aha. Now instead, this means this. So actually that function we made to loop over wasn't even needed. Okay. Now you have to figure out how many ways there are in this single race. In this example, the race lasts for okay. So this just becomes a problem of how to parse it with the white space. Because our parser isn't really set up for that. And this becomes quite a big number. Becomes this, which is a huge number. Might even be larger than our what's that, 213 billion? No, not even that. That's 116 billion. 213 trillion? 116 billion? 810 million? I mean, I could just not use this text file and parse it, just because it's literally only 2 numbers. I kind of feel that's, I don't know, it's not cheating, but it would be nice to automate it. So to turn that into a number, because if we come to our read number is using this parse int, which we didn't implement. This is from the standard library. Or I could read each of these separate numbers, and then this would be, what would it be? It'll be 68 times 10. I'll do 68 times 10 plus 87. No, it'll be 68 times 100 plus it'll be 69 times 10,000 and then 35 times a million. Is that how you would construct that number? Or would it be 10 million? Let's try that. So 35 times 10, 1, 2, 3, 1, 2, 3, plus 69 . No, I'm doing this wrong. Unless Google can just do it for me. There's an extra O in there, so it's actually, yeah, it was 1 million. 35696,887. So we would have to read how many digits there are. So we would still read our number list. How would I read how would I count how many digits are in a number? Because we're saying 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Am I overcomplicating this? Probably. Let's just do it the way where I can just skip over the white space. So while not parser is end, so we're not going to do this read number list. We're going to have a character buffer, put 16 in there. Char U8, and then we'll say, okay, if parser.peak char, or rather it's standard that ASCII is digit. Skip char, peak char, peak remaining, advanced cursor. That's a digit. We're going to say char buff, char cursor equals char cursor plus equals 1. And we're just going to say parser advanced cursor. Because we might be at the... No, we can... And then it'll be standard.fama.parseInt e32. The buff will be our char buff 02 char cursor, and it will be in base 10. And our number will be this, and then we'll do try time list append number. I'm going to make this a function. Put this down here. Read number ignoring white space. It's going to take in a parser, which is going to be the align parser, and it's going to return. Oh, and we want to type. And it's going to return that type or an error. And we want that. I'm going to put this to 32. And we'll return that number. This will be T. There we go. Let's build it. What are we getting? Oh, this needs to be try. And let me come down here 1 minute. So number 356968887, which is good. Continue. Program halted. Overflow. So this U32 might have to be a U64. So this becomes a U64 array. The answer might even need to become I64. But we're getting 205, 377, 82. I'm looking. Is that my answer? That's my answer. Is there a more efficient way to do that? Because that's bumped up our process duration to 0.2 seconds. Maybe. Maybe. So let's get started with rendering. I've downloaded some boat sprites. These are from opengameart.org. So thank you to, I guess, Game Developer Studio. I'm going to use these to render. So I'm going to come to our Raylib cheat sheet to look for rendering textures. So if we come down to our textures, these are our image loading functions. I believe we want to create a texture. These load textures into the GPU. So I believe we want this, right? So if I come into here, so we actually want a standard mem.allocator, an init function to actually store these. So c.texture2d will go in here. By default, it will be undefined because it's not loaded. And I've put this in assets boat, and then there's like different colored ones. So if we load blue, is that a PNG? We're not using the allocator, so we can mark that out. So this init function now we will need to call. So if we come back to our main Zig, we've created this interface to call the day. So we now also need our, I'll put this above, we'll have an init function pointer. So this is going to be a function pointer. It's going to take in any opaque. This is how it generalizes to all solutions, and it'll take in an allocator, and it's going to be void. And then the actual thing, which is any opaque allocator, standard member allocator, actual interface call here. We need to return pointer info pointer.child init self allocator. Or not init fn gen dot init. And then we will expose this higher up. That's all we need. Oh, of course, yeah. We can't call it init because we've already got the init. Let's call it load data. We'll just call it load, and this will be the load function. For now, we'll call it load on we'll do it here. So we'll say, okay, for days, day, and then we'll just do day.load allocator. That doesn't need to be that. It probably won't work because not everything will have. Day free solution has no member named load. Day 6 will. Well, I'm actually going to make it optional. So there's we'll say if pointer info pointer child load, then we'll do this. Has no member named load. Is there a way it can test? Like, is there a has? Is it trait? I mean, we could do this, couldn't we? And that returns a type block declaration. So we're just doing this logic to check that it has the load function. That's not going to work, so we need to do standard.mem equal u8 decl name load, and then we'll do has load fn. I don't want to be running this every time we call load, although we only call it once. But we could hoist this up here. And then this just becomes this load fn can become a optional pointer. Then we can say, okay, if has load function else null. And then we just do if self load at fn does not equal null. We will need to unwrap that. Or actually, no, we can do the typical. There we go. That should work. We're still not liking this. Oh, there is a Hasdeckel. That makes a lot more sense. Because I can make that const, right? That gets rid of all that. Days is... Oh, I need to do days dot items. There we go. So this day 6 now is now loading this. I come back to you. Our cheat sheet. So once we've loaded a texture, we want to draw a texture. So let's give this a go. So it's going to be self.boat text, and I'm just going to draw it at, I don't know, 1010. I don't want to tint it, so that'll be C white. That's all good. I need to do run. Wahey! So that's drawing the boat. Now I want to scale it and flip it. So this draw texture X, which takes in a position, a rotation, a scale. Now if I do, obviously if I do like 0.1, let me get rid of this draw texture. Now if I invert it, what happens if I do minus 0.1? Doesn't like it. I'm just wondering, can I flip it to face the other way? You can flip images and then load them. So we want that, we want to load image. And then load texture from image. So const boat file, I'm going to put that into the and then I'm guessing this might have to be var, even though I think this is just a handle. Now, I don't know if we need to, and this is no longer negative -1. There we go. Just expecting a pointer to the image. And then we'll just loop over. So we want our solution. We'll have our race list, which will be a race array. So we'll just copy that array over, right? And we just loop over it. So for I also want I, so I'm going to do the index of this as well. I'm going to draw this, so our const y pos is going to be equal to I'm going to say y index, which is going to be f32. It's going to be a float from int from the index, so it's going to be the y index times let's say 50. So this becomes y pos. This will need to be a self. We aren't using race right now. Well, there's only going to be one race. So actually, we'll do that. We'll do equals self dot race list. We'll just get the first race. And actually, this is 0 ways to win. Oh yeah, there's going to be lots of ways to win, isn't there? There's going to be lots and lots of ways to win. I might have to force quit that. Okay, let me force quit this. We can't draw all of them because that would be silly. Let me comment this out. If I come back, because there's 20 million, we'd have to draw 20 million boats. But we could draw just, what's the lowest bound? Let me just check that. We could, let's say we just want to draw 10 ways to win. And we'll separate these a bit more. So let's do 90. One, two, three, four, five, six, seven, eight. I'm going to halve the size. Two, three, four, five, six, seven, eight. And then we'll reduce. 4, 5, 6, 7, 8, 9, 10. I also want to draw the button time. So the lowest bound is going to be the race start button time lower bound. And I want to do a raylib draw text alloc print. I'm going to have the allocator. It's going to be ms let's put these on new lines. Going to be y pos maybe plus 30, and that'll be the lowest bound plus I. This is going to be int cast be int from float So there we go. Now this is a lot of milliseconds. So if I divide that by 1,000, I think we'll just have to divide everything by 1,000, so it becomes like nanoseconds, or is it microseconds? I don't know. Here's one thing. Before, in previous ones, this was const, but I'm pretty sure if I just get rid of that, it will handle it. It will still compile, yeah. So we are going to say, okay, self.race timer plus equals delta time. Very good, very good. If I do this as red, does the tint work? Sure does. Okay, so I'll make a variable called boat color. So we'll say const boat button time is going to be equal to lowest bound plus y index. This will become a float from int. So we'll draw it red or white, depending if the timer is greater than or less than the button time. So this should take about 7 seconds. Or not. Because this is in milliseconds, of course. Race timer ms, I need to multiply this by 1,000. There we go. So they're all going to happen pretty quickly because they are. So y index I'm going to multiply that by 100. I also want to draw this race time. I want to do that at 10:10, maybe 20. Which means the y pulse needs to be, I don't know, say plus 30. There we go. I've forgotten how you do this, but do you do like .0? I'll just truncate this value. There we go. And now we need our XPath, which will be a variable. Default will be 10. In fact, we will need to store this, so we'll do these boat distance is going to be 10 F32s. So we'll do 4 there we go. That should still work. We need to convert that to a pixel integer position. Or just do 0 self dot boatx dot len I self dot boat xi equals temp. So we'll initialize all the boat positions. There we go. And then we'll say, okay, we've got our boat button time. Our const is boat moving is just going to equal to this. And then we'll say, okay, if is boat moving, then dt times boat button time divided by 1,000, because we're dividing everything by 1,000. See what happens there. This becomes XPath. And then we'll also say, okay, if self, this needs to come below race. Is less than race time, then we will increment the timer. And actually, let's put that into a boolean. Is race on equals this. Or we can actually put that in is boat moving. Yeah, that makes more sense. Let's give that a go. This has to be a float from int or we'll just do const race time, which is going to be an F32. So this becomes race time. There we go. And this will begin. So I want this timer to move much quicker. So I can just increase that. It'll still take quite a long time to get to the race time, because if I move this down here, I do D, or just do race.time. That's already truncated. So this actually, if we had a couple of extra zeros in there, there we go. So I want that to be maybe Actually, we don't need to store this as a array. We can compute it because it's just how would we compute its x position given the variables we have? Rather than integrating it. I don't know. Okay, that's a good amount of time, and then this needs to come down again. And then I want this to be like 65, and I want a bigger variation. Actually, the upper bound might be more interesting in the lowest bound. Oi. I'm just doing number wang now. Because you can see each one is getting excessively better, but there must become a point where it starts to get worse. Right? Because if you hold it down for too long, what is the upper bound and lower bound again? and we're dividing that by 1,000. Well, okay, here's what I actually want. I want to take the race time and divide that by 10. Right. So I don't care about the upper and lower bounds. Or divide that by self.boatx.len and times that by I. Might complain about this. Okay, that makes more sense. And then this needs to become like, I don't know, 1 million. There you go. That's what I was expecting, more of a curve. That's cool. So there is sort of an optimal. See, that would have been better for the maybe part 2, is like find out the actual optimal time rather than just a range of them that are above a certain threshold. But it was still an interesting problem. Okay, so I just want to move this answer thing over. So I'm just going to move that over, like, I don't know, 200, tidy this up a bit. If we release C dot I'll reuse space. I want to reset self dot race time ms to 0, and I want to reset all the boats. well, we'll say 0. And then we'll just add in this xpos plus 10. Or we'll say, okay, const final xpos equals xpos plus 10. That way I can restart it. That needs to be even more over. And there we go, that is day 6. Thank you very much. I will see you next time for day 7. Bye.